All right, as part of the lesson today, I'm going to demonstrate how to establish a tube frame using the 3-point method. Again, you got to establish a tube frame so that the robot knows where the end of arm tooling is located. So remember from our lesson, when the robot comes in, the default tube center point is at the faceplate. Okay, so we need to establish a tube point that is in another location. So we'll be using the 3-point method again to establish that point so the robot knows where that is. Okay, we need to establish this tube center point for our upcoming labs that you'll be participating in. So again, for the purposes of this demonstration for the video, I will give you a visual of what it's supposed to look like. And then when we get to your labs, you'll be actually jogging the robot to these approach points and then recording them. But as I go through the video, I will talk through some of the keystrokes that are involved with recording your tube center point. Okay, so remember, we need this information so that the robot knows where the work is going to be done. All right. Again, our application is a pointer that is held in the gripper. Other applications could be, welding tip or some other type of application that the robot needs to know where that work is being done. All right. So I've already established a tube point. I will use that tube center point to move the robot to our approach points. Just to speed up the process, again, to give you a visual to let you see what it's supposed to look like. But in your labs, you will actually have to be responsible for jogging the robot to your approach points. Okay? So I have a home position established right now for the robot that I will be returning to in between my approach point moves, just so that it's a little safety that we use here in the class. A lot of times you can get into trouble with the robot hitting some things if you try to move from one approach point to the next. So I'll have a home position established, and I'll show you what that looks like as we move from approach point to approach point. All right. So I will go ahead and move, jog the robot to our very first approach point, and then I will talk you through the keystrokes that are involved with recording that point. Alright, so again, I've got a tube frame that's already established, and I will be using that tube frame to demonstrate how the robot should look at each of the approach points. Again, you won't have this luxury when you do your lab. Alright, so now we'll have the robot moving to our very first approach point. Okay, and there it is. Again, this approach point could be anywhere in the workspace. Some manufacturers or companies will have a fixture tool that you will use to set up your tube center points a lot of times. This is what we'll use here for the purposes of our labs. So we've got our robot in position. Our pointer tip is directly above the tip on the fixture tool, and it's a good position, so I'll go ahead and record that position. Okay, so the process, once you've got your robot in position, is to go into, again, you would have jogged your robot into this position. So once you want to record a tube frame, okay, you will hit your menu key. You will cursor down to setup. Once setup is highlighted, You will cursor over to the next page, cursor down to frames. Once frames is highlighted, enter. Okay, this one happens to be defaulting to the two frame I previously set up. Okay, so we want to go to the previous menu. Okay, and that will highlight all of the two frames that are available for you to pick from. All right, so each one of you will have your own two frame number, and you'll need to remember what it is. Okay, so for the purpose of our class, our two frame and our user frame numbers will match. It makes labs a lot easier. Okay, so once you've identified a number that you want, cursor down to that number. For the purposes of this lab, I'll be selecting two frame number 10. So I'll cursor all the way down to 10. Make sure my cursor is at 10. Okay. Once I get my cursor in the correct position, I'll click the enter button, and then the two frame will come up for two frame number 10. Okay. This one happens to be defaulting to the direct entry method. Okay, so we'll be using the 3-point method. All right, so again, the 3-point method will allow us to demonstrate to the robot the location of our end of arm tooling. Okay, so to change the method that we record in, you will mash the F2 method and cursor up to 3-point. It just so happens to be defaulted. And we click enter. And so now we have our 3-point method page highlighted on the screen. Okay, we can add a comment. So when you pull that page up, it's automatically the cursor is in the comment section. If you want to add a comment, I recommend you do add a comment for the purpose of your lab. Put your initials and your two frame number. That'll help keep everything together. Okay, we put that information in. All right, so now that we're at our approach point 1, okay, on your two frame page, you will need to highlight approach point 1 with your cursor. All right, then you will mash Shift F5 record. Okay, and then you will see that point be labeled as recorded. Okay, that lets you know that the robot has recorded that position. Okay. Now, this is your approach point 1. Okay, so I'm going to move back to my home position in order to move to our second approach point. I'll speed that up. Again, you'll be jogging the whole time in either your joint coordinate system or your world coordinate system. Again, this is just for demonstration purposes only, so you can see what it's supposed to look like when you get to your lab. Okay. So again, I'll use a previous two frame to move the robot to the next point so you can get an idea of what it's supposed to look like. So So again, this is a previous two frame that has been established, and we'll be using it to show you what it's supposed to look like. Again, when you get ready to do this in the lab, this is all the movements you'll need to jog the robot into position to record. Okay, so now our approach point 2 that we have here, all right, it's 90 degrees from approach point 1. Okay, the closer you can get your approach points 90 degrees of one another, typically the more accurate a setup you'll have. Okay, so when we do approach point 3, it will be 90 degrees to approach point 2, which will also be 90 degrees to approach point 1. Okay, so we are at our approach point. Okay, so again, we use the same technique. Okay, so we cursor down to approach point 2. Make sure our cursor is on approach point 2. Mash shift F5. And again, the display should say recorded to let you know that that position has been recorded for approach point 2. Alright, so again I'll move back to our home position that we had recorded. Safety purposes and for demonstration. It helps a lot of times for students to see it first before they actually get into the lab to see what it looks like. So hopefully this will help you visualize what it is you're trying to accomplish when establishing a user tool or tool frame. Alright, so we'll go back in the up. Now we will approach our last position here. Again, approach point 2 was 90 degrees to approach point 1, and approach point 3 will be 90 degrees to approach point 2. Okay. So again, the more accurate you can make your approach points, the better setup you will have. Alright, so now I'm at our approach point 3. Okay, again, the 3-point method is just going to establish the location of your end of arm tooling to the robot. If we use the 6-point method, again, that does location and orientation. But for right now, we will just use the 3-point method. Alright, so I'm at my position. So again, I need to make sure that my cursor is down to approach point 3. Okay, the approach point 3 is highlighted. Mash shift, F5 record. Right. Now, once you record the approach point 3, all your values will populate up in your XYZ yaw pitch and roll. Okay, your yaw pitch and roll is going to stay 0 again. We're just doing location. All right, so your X, Y, and Z will populate as to what the positions are. All right, so now that we have established our tool center point, we can then come in and validate to see if it actually is accurate. All right, so I'm going to move back to our home position. All right, shift move 2. All right, very good. All right, so now we're going to verify that we have recorded an accurate user tool or tool frame. Okay, so we're going to move back to our approach point 1. Now, if you've done this correctly in your lab, okay, remember how to get to the jog menu, mash shift plus coordinate, and your jog menu will come up in the top right hand corner of your screen. You want to make sure that your tool number is the tool number you just set up. So in our particular instance, it's tool 10. So I'll type in 10. Alright. So now I have identified to the robot that tool 10 is a tool frame I'm going to be working with. Alright. So now I've got that identified. We'll go into our tool coordinate system, and if I use the J4 and J5 axes, it should rotate about that point at the end of our pointer. So let's see how we did here. Alright, so I'm going to mash my coordinate key till I get to tool. Alright, and then we should be able to rotate our robot about that point that we just established. So let's see how we did here. Let me turn speed up. Again, I'll be using the J4 and J5 axes, or yaw and pitch. Okay, I'll start with the J5 first. Okay, so you can see then that the robot's coming to you and away from you, but my tool center point is staying over the point that we established. All right, here's our J4. So you can see that the point is stationary. All right, the robot is rotating about the tip of our end of arm tooling, or our pointer. Okay. So I'll show you what it looks like if you, for some reason, you didn't get the correct positions recorded. You can get it incorrect, and it'll look something like this. So this is what I'll do. I'll select a tool frame that does not have any values in it or has not been recorded. So I'll go into my jog menu, which is shift coordinate, and I'll put in a tool here that does not have any values in it, hadn't been set up yet. And then we'll jog the same J4, J5 axes, and it should rotate about the robot's faceplate. Okay. Again, it has not been established, so the robot thinks that the tool center point is a faceplate. So let's see how we do here. So now I'm still in the tool frame. So if I shift and use my J4 or J5, it should rotate about the faceplate. Okay, and it does. So you can see our tip of our pointer there is moving away because the robot is rotating about the faceplate. Okay, same way with our J5 axis. Okay, so if you get something that looks like this in your lab after you've established your tool center point, you may have done something incorrect. So again, I'll go back to our tool that we just set up, shift coordinate, tool 10. Okay, and we'll try it again just to make sure we're back in our position here. So if we do our J4 right here, which is our yaw, again you can see now we are rotating about the tip of the tool. All right. So again, this is just a visual illustration of what the three-point method should look like. When you get into your labs, again, you'll be jogging the robot using the joint and world coordinate systems to put the robot in each of the positions, approach point 1, approach point 2, and approach point 3. We'll try to remember the 90 degrees from each other. The closer to 90, the better, the more accuracy you'll have in your setup. Okay, so I appreciate you not asking questions till the end of the class here. Hold your questions to the lab, because I know there'll be some. But again, the importance of establishing a tool center point or a user tool is to let the robot know where the end of this end of arm tooling is. It needs that information in order to perform robot operation. Okay? If there's no user tool defined, it will default to the faceplate. Okay, so if you inadvertently leave out the user tool information and you create a program without some user tool defined information, the robot again will default to the faceplate, and you could run into a collision with something. Alright? Very good. So I'll look forward to seeing each one of you complete your labs, and hopefully this visual demonstration will help you complete that lab a little faster, a little better. All right? Very good.